All right, we're back. We are on page 109 of Math Analysis, notes 10. We're talking about solving oblique triangles, which means find all the angles, all the sides of a non-right triangle. And so far what we're doing is using the law of sines to accomplish that, which means that we are given an angle side pair, right? So angle A, side A, angle Z, side Z. We have a pair of those, and then we have either another angle or another side. If we have another angle, it's straightforward. You just use the law of sines. You're basically done. If you have another side, it's the ambiguous case. All bets are off, and you got to kind of like work your way through. There's a path that you can follow, right? So is the side opposite the angle greater than or equal to the other given side? One triangle. If not, is the side opposite less than the height, right? So the height is the sine of the angle times the other given side. That's your height. So is the side opposite less than the height, in which case no triangles. You just kind of like dangle in the air. And then is opposite greater than the height? If so, two triangles, because then you have height is the smallest thing, opposite is next, and then other given side is the biggest. If you have that inequality, then you have two triangles. And then it's also possible that the side opposite is exactly equal to the height. Like it's possible, but never happens in practice, because then you have a right triangle. So let's see if we can solve this. So we are given, I mean, we're told to solve both triangles, so there's obviously two. But you should always like go through the process. So ZM, and then what, triangle TMZ. TMZ is probably watching some trashy TV at the time. All right, let's see. So I'm gonna draw the triangle, right? And it's not a real triangle, it's just a representation of our data here. All right, so this is gonna be Z. So this is 41, and then this is 12, and then 16, right? So what we have is an angle, side opposite that angle, and then we have some other given side. We have to decide how many triangles there are. So the side opposite is not bigger than the other side, right? 12 is less than 16. So immediately I'm going to calculate the height. So the height is going to be 16 times the sine of 41. So where's that coming from? That's other, and then the sine of the angle. So I need a calculator for this. I'm actually just going to do it. I'm not going to bother to switch. So I'm in degree mode. I'm doing 16. Somehow I'm doing this. 16 sine of 41. I get 10.497, let's say. So this is approximately 10.497. Okay, so what's happening is I have an inequality, right? And my inequality is H is the smallest, then opposite, and then other. And when you have this relationship, you have two triangles. So the side that's 12 swings down, hits once, keeps swinging. It swings past the height where you would get your right triangle. So your height is here, swings past there, and it connects again. It doesn't like go outside of the triangle. It actually connects again. That's where you get your two triangles. So let's see if we can solve them. So the first thing we're going to do is, I know there are two triangles. So usually what I do is I just set up the information, right? So I know that I can do this down below too, but I'm going to say TMZ with TMZ, a lot of equal signs. We can fill in what we definitely know, right? So we know that Z is 41, and this is 12, and we know that M is 16. Looking at this set of information, there's actually only one thing you could do, right? We have a side angle pair. The only thing you could actually do at this point is use the law of sines to find angle M. Like that's it, there's no other option. But we know there's two triangles, so let's set up our other one also while we're here. I should just copy and paste this. But that's just not, you know, I didn't grow up that way where you could copy and paste your writing. I actually used to be really skeptical about like writing on a tablet in general. Like I thought that's never gonna take off. Well, I was wrong. Or I mean, I guess it, like, I don't know if it's taken off in general, but for me, it's like all I do anymore. So it did take off in my case. All right, so we have our two sets of information. I'm gonna use the law of sines to find angle M. So I know that the sine of m over m, so over 16, is the same as the sine of 41 over 12, right? So I know that, let's just directly, we'll say m is the inverse sine of 16 sine of 41 over 12. All right, and then that's a calculator problem. So I'm going to calculate that. Then I'm going to do something crazy. Well, it's not really that crazy. And if you've been paying attention, if you did the GeoGebra thing, maybe go back and do the GeoGebra thing again. Like keep it in the front of your mind. You'll know why I'm doing what I do as soon as I do it. So I'm going to do like M1, I guess, for the first version of M. Is it inverse sine of 16 sine 41 sine, nope, 12. And I'm putting a decimal to get a decimal answer. So I get this, so 61 point, I'm gonna handwrite this in right now, 61.015. 61.015. Okay, now, right now, what I'm gonna do is I'm gonna find the supplement of that. The supplement of that is the obtuse angle that's in the smaller of the two triangles. I'm going to call it M2. M2 is 180, the supplement of M1. So M2 is 118.985. 118.985 degrees. Okay, let me go back to the written notes so I can show you what's happening here and make sure you actually have done this. So the key is we figured out, so the law of sines, when you use inverse sine, it always gives you an acute angle because arc sine is only defined in quadrants 1 and 4. We're always doing the inverse sine of a positive, so it's always a quadrant 1 angle, and those are always angles between 0 and 90, so it's always acute. So the law of sines has no choice but to give you, let me highlight here a little bit, this has no choice but to give you this acute angle. Like it will always do that. I should put a degree sign there. Okay, now what we did immediately was we found the supplement. And the reason we found the supplement was that isosceles triangle that you see if you go back to the GeoGebra thing and you show the small triangle and the big triangle at the same time. I can kind of handwrite it. It's not going to look great. So we got this. Let me just, let's say it's like this. And then, well, you know, colors. Let's use different colors. All right, here we go. Being victimized by my artistic ability. Here and then here. These are the same. So this and this, right? So this is the angle that the law of sines found it, right? But these are the same, which means that if we take the supplement, we will get this. Those are different colors. I don't know if you can tell. So that's why we took the supplement. Once we've done that, now you just solve it like two entirely separate problems. So you just say like, all right, now I'm going to solve these two. So let's actually do that. So we can find t. So t, I'm just going to do 180 minus 141 minus 61.015, right? Then I know that I'm going to end up finding, let me see here. For my first triangle, it's going to be, well, actually, it's for both of them. It'll just be a different thing. So t over the sine of t is 12 over the sine of 41. So I'm going to say it's 12 sine of 41 over, what am I doing? I'm doing that wrong. Hold on, 12 over the sine of 41. That's a given. 12 over the sine of 41. It's a given that I'm getting it wrong. And then this will be the sine of t, let's say t1. And then over here, we'll have the same thing where t, let's say these are little subscripts, t sub 2 is going to be 12 sine of whatever we get for t2 over the sine of 41. All right. I'm always like so eager to just kind of I'm always eager to get to the answer. So like my work gets bad. So this will give me this. And then, I don't know, this is going to give me this. All right, calculator. Let's go to the calculator and see if we can make this happen. So I mean, it takes a while to solve a triangle that has two triangle solutions. Doesn't take as long as it's currently taking me, and it won't take you this long either. So we need to find T1. So 180 minus 41 minus M1, right? That angle that we found, 77.985. So I'm going to write that in, 77.985 degrees. And then we are going to do 12 sine of, I'm just going to use the answer, right? So sine, this is the T1 that I hand wrote before, and then sine of 41, and I get 17.8903. 17.890, I guess. And that's not in degrees, even though I put a degree sign, but you can't see that, and I erased it, so that's fine. Now let's do the other one, right? So 180 minus 41 minus M2 gives me 20.015. 20.015, that's degrees. And then what I can do is actually just go up here and delete this and change it to answer. And I get 6.26, 6.260, not in degrees. And then we can check this sort of, like not perfectly, but you can do like the sine of, I need the 70, see this, I should have stored things along the way, but I didn't, over this, I mean, this is pretty, oof, that didn't work. I'll just type, so this is going to be off by a little bit. Basically that, and then if I try to do the sine of 61.015, which is not exactly right, over 16, oh, super different. So different that I'm wondering if they're even right. Let's try the sine of 41 over 12.05. So this is the one that was like way off, but this has the most rounding in it also. I don't know. Yeah, I guess I could go up and store them. Let's do that. So 17.89-ish. I'm gonna make you, let's store this as T1, I guess. This will be that. And then T1 side, I guess. I'll make 17 point, oh wait, 7, everybody, I have regrets. All right, T1, I'm gonna store as 77.985, which maybe I just did, but I don't think I did. All right, and then T1 side, I'm gonna store as 17.89. All of this because it just didn't go well for me. Here we go. Okay, let's see what this gives me. Sine of T1 over T1 side. 0.05, I don't know. Now it's the same. That was like so wildly off before when it was all rounded. And that's kind of what happens. So let's watch it happen again. Sine of 41 over 12 should be equal to the sine of, did I store this as M2 maybe? Okay, over 16. False. Ugh. I knew it was going to be false because of the decimals. You know, like you just get killed on all your like rounding here. Like for our purposes, those are definitely equal. They're not, according to the calculator, they're not equal at like the 32nd decimal because eventually it has to round. So this is not going to work at all. But let me try it. 0.015 over 6.260. This is going to be way off. Oh, wait, that's not way off at all. All right, that's good enough. I'm going to take that. I wonder if I just typed it wrong before. And I think I deleted it, so I can't even see it. When I got like this one, 17. Oh, I'm so dumb. You know, all of that, I didn't need to do any of that. I needed to use the angle. I should have done the sine of the angle divided by the side. I did the sine of the side, whatever that means, divided by the side. That was stupid. That's my bad. I wasted everybody's time. So let's go back. You know what? Maybe I'm gonna finish this page, I think, because you know, if you have the answers and you're happy, like, you know, get out of here. But if you're interested, the bottom of the page there is a picture that does have the isosceles triangle. So I just want to point out this angle right here, this is the one that the law of sines finds. So the law of sines finds that. Right? And then it's isosceles. So this will be the same. Strictly because this is isosceles. And then this is the supplement. So that's why when we did this, we use the law of sines to find the only thing you possibly can. And it's going to be the acute angle in the giant triangle. Then you find the supplement of that, and that's going to be the obtuse angle in the smaller little triangle. And the isosceles triangle is just like a convenient thing. Like it's not really a part of the process. It just coincidentally is there, and it helps us solve it. But anyway, sorry I messed that one thing up. And then I guess you got to learn a lot about how to store things on a calculator because of that. But I'll be back in the next video, and we will keep going. So I will see you there.